Okay, good afternoon. I'm Roch Guérin from University of Pennsylvania, and I'm going to talk about things that have been actually touched on by several people, probably trying to take a slightly different tack and provide some additional color. Before I jump in, I just want to acknowledge that it's obviously not me alone, and whatever stupid thing I'm going to end up saying today will be all mine, however. So the first thing is really, I think, and we've heard that several times, right, is that the key to resiliency is to have multiple choices, because when one thing goes bad, you like to have a backup plan, right? And in the context of network, that typically means that you have multiple paths, right? So the path being the chain of communication that you have between a source and a destination, and you do want to have more than one, because when one goes away, that's the only other alternative, right? And routing is, to a large extent, in communication network, what enables you to take advantage of whatever diversity might be available. So, what I'm going to try to talk a little bit about is primarily around things that are related to how we discover those paths and how we're going to be using them in different types of network, right? And there are really two different ways that you can think about it when you have that diversity. One of them is you have things set up in advance, they're there, and so if one of them goes away, you're just running on 3 legs instead of 4, and still, you're fine. The other one is you're reactive, and then you discover that the path that you were using suddenly went away, but there are other ones, and then you have to actually find them, right? And so there are a lot of differences in those two things, but the basic question that we're trying to sort of address and understand is, what does it take to actually put the diversity in place, discover it, and then use it efficiently so that when bad things happen, we're not completely at loss, right? And so there's a whole spectrum of things, and I'm going to be looking at 2 points on that spectrum. One of them, which is a very large scale, the internet, right? And what kind of diversity is out there, and then how do we use it? And the other one is more at the at the small scale, where we can talk about the social networks, the resilient social networks, but it's like a small mesh network, and you like to make that resilient and able to have enough diversity so that when things come and go, you don't have a problem. So I'll touch on these 2 extreme points. They have, however, something in common, right? It's like if you look at the internet, if you are in a reactive mode, it's going to take a while for you to find the backup. Right? And I'll speak a little bit more about that later on, but the thing that's so big is that the routers, the devices in the network are going to start hunting for this alternate path that might exist, and eventually they'll find it, but before that happens, quite a bit of time may have elapsed, right? And so ideally you'd like to have a solution where everything is ready to go. In the mesh network, you are in a similar situation for very different reasons. Right? Namely, things are often unpredictable at a time scale that is such that if you try to react to it, by the time you've reacted to it, it may have fixed itself, right? And so, often you don't necessarily want to have this sort of approach to dealing with the problems. So, that's sort of the thing that ties these 2 extremes together in the context of multipath. Right? So, internet scale multipath, right? So I think the first question that I'd like to touch on is, do we have a chance, right? Is there indeed appropriate diversity at an internet scale? And I think by and large, we have information that tells us that there is physical diversity. We have links and routers, they connect in ways where we don't have this unique tree with no alternate path, right? The problem is that the internet is just not only the links, is that a whole bunch of protocols and policies. So the way the internet works is that domains talk to each other, and policies that are in place tell me that, oh, you can use that domain, but not that one. And so yes, I have a wire, but my policies are telling me that I cannot really use that wire for all intent and purposes. So connectivity may be feasible, but prevented by various policies, right? And actually, there's been a number of studies that have been done on a couple of sample parts of the internet that sort of say that roughly it can cost you about 50% of your backups just because of the inconsistencies and the limitation of those policies. Right? So the first thing that I want to really talk a little bit about is what kind of diversity is there that is actually accessible. that we could take advantage of to get those backups that we're talking about. And so that means building a map of the internet, and there are various sources of information that you can tap into. CIDA, and we had one from CIDA this morning, provide some of that. There's another at UCLA called Cyclops. So essentially it's a database that's telling you, okay, who connects to whom in the internet. Once you have that map, then essentially it's a pretty big map, and you have to then try to crunch the numbers to figure out, okay, what diversity is available there. So let's first look at the map, right? So in the lingua of the internet, an AS is a domain, right? So it's one of those things that is making up the internet, and they are at different levels. So tier 1 are the big guys. They all talk to each other, and they have pretty much global connectivity. And what I'm calling by tier 1, 2, 3, 4, 5, 6, it's basically telling you how far are you from the top guys, right? So if you want to talk to AT&T or Sprint, who are tier 1 providers, if you're tier 2, you mean you're directly connected to them. If you're tier 3, you are 2 hops away from them, right? And so you can see that the graph of the internet is sort of this thick waste, right, with very dense connectivity, right, and then you're going further away. So it does look like there is quite a bit of diversity that's available in there. And if you look at how many people different places connect to, obviously the big guys, the tier 1, connect to lots of people. So the degree means how many other domains are you connected to. So on average, a tier 1 guy connects to close to 1,400 other people. So it's pretty rich, pretty dense. Obviously it drops off, but this is sort of a relatively rich graph. And so this gives us a good shot at having diversity. This is just looking at how many people can you reach. And again, this just confirms that barring other problem, we should see reasonably good diversity. Right? So this now is essentially saying, okay, now that we've seen this graph, now that we've seen this map, right, how many places do I need to cut in the internet to disconnect you, right? So what we're plotting here is a min cut, which basically saying how many links between domains should I cut in order to disconnect you, right? And so it's picking a whole bunch of domain, and it's looking at all the other domains that they want to talk to, and it's saying on average, if I cut a link, how many of them do I need to cut in order to disconnect you from the rest of the internet? And this is looking at not people that are connected by just one link, right? So this is looking at only at people that are connected by at least 2 places. Most domains are so-called multi-home, right? So they don't want to take the chance that if the primary link goes away, they're completely disconnected from the internet, and so they usually have 2, sometimes more, of those links connecting them to the bigger internet, right? And so the good news is that it's telling you that actually, even for the people, this is an average. It's basically saying if I look at everyone that you want to reach in the internet, right, what is your resiliency in terms of alternate paths that you may have? And, it's, oops, it starts at close to 2, which, anyway, you cannot, if you are at 2, you cannot do more than 2. So we do expect people who have 2, which is exactly what we're seeing. And the good news is also that the variability is actually relatively small, right? So by and large, what this is telling us is even after taking into account all the limitations that the internet protocols, in particular BGP, are imposing, this is where we are. All right, I will skip quickly to the second one, right, which is the the mesh network type of environment. There, the problem is a little bit different, right? The problem is that links fluctuate. They come and go. And in this environment, what we want the multipath to do is give us multiple options to get to the destination, right? And we're going to be using those paths at the same time, so that if one link goes away, we still have one leg to run. And so this is, on the left, giving you a realization of, in that network, what you have. You can either pick the best path, so you figured out this is the most stable one, and you put all your eggs in that basket, or you can try to go after multiple paths, right? And then you actually are seeing, sometimes you lose one leg, sometimes you lose a second leg, sometimes you lose a third, right? And you pay a little bit of a penalty in terms of a slight drop in the rate that you're able to achieve. but you realize a drastic benefit in terms of the variance, right? And you see it actually even more accurately here, where if I look at the dead times, how often am I completely disconnected? You see a much smaller, both in terms of percentage and in terms of duration, fractions of dead times if you're able to actually spread your communication across multiple paths. So I'll just wrap things up here, right? So there is multipath that's available both at the large and the small scale, both the internet and small networks. It affords significant benefits in terms of resiliency, but there are actually problems if you want to actually use those multipaths pretty consistently. And I'll just give you one example. This is what happens with TCP if you use multiple paths. You send your packets over multiple paths, you see a drop in performance. Why? Because TCP as a protocol doesn't like it, right? And so if you really want to move in this direction, which can improve resiliency, you actually have to develop solutions that combine both network approaches and things that we need to do in the end system. And there are actually efforts going on, in particular in the case of TCP, that can help in that area.